Hello and welcome to today's webcast brought to you by Cabling Installation and Maintenance. Today's event, The Importance of Network Identification, will be presented by Jay Whitaker, Business Development Manager with Panduit. The webcast is being sponsored by Panduit. Our thanks go to Panduit for making today's event possible and for providing the technical content within it. Today's webcast addresses both the why and the how of network identification and administration, specifically including the specifications and best practices spelled out in TIA 606B. Jay Whitaker will walk us through the 606B standard, including its classes of administration, identifier schemes, and requirements. He'll also highlight some identification solutions available to ensure systems are administered according to 606B. We will have a question and answer session at the conclusion of this presentation. You can submit questions at any time by clicking on the Ask a Question button that you see in your presentation window. If you're running pop-up blocking software, you'll need to disable it in order to view this webcast. We also recommend that you close other applications on your computer for best performance. This seminar qualifies attendees to receive 1 ITS continuing education credit from Bixby. To receive the attendance certificate that enables you to obtain your credit, you must remain online throughout the duration of this webcast, including the Q&A. When it concludes, you'll see a pop-up window on your screen that lets you know you've successfully completed the seminar. That's another reason that we need you to disable a pop-up blocker, because it is a pop-up that actually acknowledges your full attendance today. What happens after you see that pop-up is a message will be sent to the email address that you provided when you registered for this webcast. That email will bring you to your attendance certificate. So thank you once again for joining us today, and it's my pleasure to introduce today's speaker, Jay Whitaker. Jay, whenever you're ready.
Thanks, Patrick. Hello, everyone. Thanks for attending this webinar. My name is Jay Whitaker. I'm Product Manager with Panduit Identification Products Division. Just a little bit about Panduit. Panduit is a world-class developer and provider of leading-edge solutions that help customers optimize the physical infrastructure and mitigate risks through simplification, increased agility, and operational efficiency. We've been an independent leader since 1955 with a global presence, local focus, and customization. Panduit has over 4,000 employees. We operate in 112 countries, and we provide solutions for data centers, enterprise, and industrial automation. So today we want to take a look at network identification standards, specifically the TIA 606B, classes of identification that are in that standard, identifier schemes, requirements for records and labeling, and then some identification solutions that are available for network applications. So what's wrong with this picture? This is a lot of things going on wrong here. Poor cable management. There's general chaos with the network cabling, and there's no clear identification. So why spend time and money to identify physical infrastructure in your network? This is a picture we want to see. We've got clear, properly identified cables and connections, and the advantage here is that a properly labeled infrastructure is a system with components that are going to be quickly and accurately identified, which is going to reduce the time to repair and ensure maximum availability of business IT services. So it's a lot easier to repair, maintain, and install a network if it's properly identified. So how do you go about doing proper identification of your network? Well, fortunately, we have a lot of excellent standards from TIA that will provide guidance for network identification. The above standards were all developed by consensus of technical committees that were comprised of professionals from product manufacturers, network designers, and engineers. The resulting standards provide a good foundation for the design and management of telecommunication infrastructure. So one of the questions I get a lot, and there seems to be some confusion about 606A, 606B, and where it all fits in. And this slide kind of gives a good overview of the development of network identification standards. Originally, there was a 606A that was introduced back in 1993. and it established guidelines for the administration of telecommunication infrastructure. It had a scalable and modular implementation of different elements of the standard and provided identification scheme for specific connections, including floor and space, rec designation, and port numbers. And some of you may be familiar with the old standard, which was FS-AN, which was it worked really well with the small like enterprise-type networks where you have a telecommunication closet and then you have workspaces or offices that are being administered. In 2005, TIA introduced the TIA 942A standard. And this is a standard that specified the minimum requirements for telecommunication infrastructure of data centers and computer rooms. The standard provided an informative reference to the TIA 606 standard for guidance on data center administration and labeling. At the time, that was really the only reference that was available, and people tried to use the 606A standard in identifying and administering a data center, but it proved that it didn't really, in practice, work very well. One of the problems with using 606A was that there was a huge amount of structured cabling in a data center, lots of cabinets and racks, and the labeling scheme in 606A didn't really address that very well. So the TIA committee introduced an addendum to 606A, which was Addendum 1, which specifically addressed the administration labeling in the data center. And this introduced a new identifier scheme, which is FSXYRP, which is the floor space, the rack, the panel, and then the port. So it added an additional dimension to the identifier scheme of the actual rack or cabinet that's in the data center space. So we had these two standards, the main standard, the addendum, and TIA went about in 2012 introducing the 606B standard, which was a complete revision of 606A and the Addendum 1, along with additional telecommunication infrastructure elements. The standard allowed for the legacy 606A identifiers like the FS-AN and provided an ISO IEC compatible identifier scheme for multi-region facilities. So the nice thing about the 606B is you have a global network to manage. You now have a standard that you can use that will work in North America and will also work in other parts of the world. So that was one of the nice things that was added to 606B. In addition to the ISO and IEC compliance, we also added information in the standard as far as the management and administration of grounding and bonding systems, the use of automated infrastructure management systems, and the introduction of administration for individual pair groups or fiber strands. So this new standard, 606B, addresses just about every aspect of a network that you may need as far as administration and labeling. So looking at the scope of 606B, it accommodates the scalable needs of telecommunications infrastructure systems. It deals with commercial, industrial, residential, and data center premises. It allows for modular implementation of different elements of the standard, depending on the size of the telecommunication infrastructure. And this is key because you can use this standard either for a single telecommunications closet in a small office building to multi-campus network around the world. It's very modular and scalable. It specifies the formats and requirements for records, identifiers, and labels that are used in infrastructure components. So the 606B standard is scalable and addressable in addressing the network administration requirements based on size or class of telecommunication infrastructure. A Class 1 addresses the administration of infrastructure with a single equipment room. Common elements in the Class 1 administration are horizontal links, cabinets and racks, ports, and grounding and bonding components. With the Class 2 administration, we're addressing the administration of a network with multiple telecommunication spaces in a single building. The requirement for this class increases to include backbone cables and fire stopping locations. So now we have grown from a building with only one equipment room to a building with one or more additional telecommunication spaces. Additional items to be administered in this class are backbone cables and fire stopping locations. In a Class 3 administration, the needs of telecommunication infrastructure with multiple buildings at a single site are addressed. In this class, we add the requirement for inter-building cabling, pathways, and access locations such as manholes and cable vaults. And then finally, in Class 4, we have multiple campuses that are being administered. So the three key elements required by the TIA 606B standard to effectively administrate telecommunications infrastructure are identifiers, labeling, and records. The identifiers are simply a scheme of numbers and letters that are assigned to each component in a physical infrastructure. An organized identifier scheme will assist in easier moves, adds, and changes in the future, as well as help organize the infrastructure test data. For labeling, the identifiers are then printed with a mechanical device on the labels and applied to the components. Keep in mind that the full identifier is not always required on the label. Only the information that's not obvious to the user is necessary on the label. For example, floor and space information would not be necessary on cabling within a data center room. The standard also requires that all identifiers, test data, and infrastructure history are recorded and maintained in records. These three elements perform to create a fully documented infrastructure that will easily accommodate moves, adds, and changes and assist in future troubleshooting needs. This training session is primarily focused on the labeling requirements of the standard. So looking more in detail at what's required in a Class 1 identifier. The following infrastructure elements need to be identified: telecommunications space, cabinets, racks, enclosures, or wall segments, patch panels or termination blocks, patch panel ports and termination positions, cables between cabinets and racks and enclosures, the cabling subsystem 1, which is also known as a horizontal link, equipment and work area outlets, telecommunication main grounding bus bar, telecommunications grounding bus bar, the rack grounding bus bars, and then the bonding conductors, such as the bonding conductor for the telecommunications system, the telecom bonding backbone conductors, and grounding equalizer conductors. So these are all requirements of a Class 1 infrastructure. So looking at each of these in a little more detail, let's look at the floor space. This is a good place to start if you're trying to implement the standard for your network, is to first identify all your spaces, whether they're data centers or telecommunications rooms or telecommunications closets. Go through and identify all these spaces. And the format or the identifier for telecommunications space consists of an F for the floor and an S for the space. The identifier in this example is 2A, so this identifies this space as floor 2 and its telecommunications space A. Another example would be you could possibly use a 1 DC, so first floor and it's a data center space. So once we've identified the telecommunications space, we can add to that identifier the location of the rack for the cabinet in that space. Cabinets and racks should have location labels applied to the top and bottom of both the front and rear of the device. These labels should be visible whether or not the doors are closed or open. A lot of times the doors are removed from cabinets for adding components. So it's important to have it labeled inside as well as on the door. The floor tile or grid designations are used to identify each cable or rack location in a data center. So you basically have an XY grid on the walls of the data center, alpha on one side, numeric on the other. The cabinet rack location is based on which floor tile the right front corner of the cabinet or rack rests upon. This identifier would define that this cabinet or rack is located at the right front corner of the intersection of row AY and column 15 in the data center space. The standard also addresses a situation where floor tiles are not in use. For these situations, rows and cabinet positions in a row can be assigned in the data center. For example, you could use row B, cabinet 3. In telecommunications rooms, floor-mounted racks and wall-mounted termination blocks can also be assigned a sequential number instead of using the grid coordinates. So there's a lot of flexibility in the standard to address these different situations, but most common in data center would be using the XY coordinates. Okay, so we've identified the space, that's your FS in the identifier. We have the rack location, which in this case is the XY location. And then we're going to add to that the panel identifier. The designation for panel positions in a cabinet or rack can either be alphabetic designation or preferred is a 2-digit number that represents a rack unit number or RU number where the top left mounting screw lands in the cabinet or rack. By using the RU method, this provides the data center manager with greater flexibility since it allows for panels and equipment to be added or moved later and not disrupt the designation of panel identifiers. This identifier would define that the top left mounting screw of the panel is located at the rack position B in the cabinet or rack located at the intersection of row AR and column 15 in the data center. So the next thing to add to identifier is the actual port. Again, we have the floor space, which is the FS part of the identifier, the rack location, the panel position in that rack, and then the port position. Port identifiers are very important in that they define the connectivity of cabling within the data center infrastructure. If the patch panels are not pre-printed with port numbers, then labels will need to be created to identify the port numbers. The numbering sequence should proceed from left to right, top to bottom for all ports on a patch panel. The number of digits used for all numbers on a patch panel should be consistent with the total number of ports on that patch panel. For example, on a 48-port patch panel, you would want to have numbers 0, 1 through 48. On a 144-port fiber panel, you might want to have it labeled 001 through 144. The identifier in this illustration defines that this is port 12 located on panel 24 in cabinet rack AB04. For the identification of fiber adapter panels, each panel can be assigned a letter, and the ports on each adapter panel sequentially numbered. So for example, in the top picture, we have a label that defines this fiber adapter panel. And we have basically A for the first adapter panel that's been numbered 01 through 06. And it's located at the 30th RU position in cabinet AC12. It also connects to ports 01 through 06 on a panel located in the 20th RU position in another cabinet, which is AC04. Also for pair groups on punch-down blocks. For identification of pair groups on a punch-down block, designation strip can be printed with identifiers for each pair group. So now that we've identified the floor and the space, the rack location, the panel locations, the port locations, we wanted to define the connectivity between ports or groups of ports. And to do that, for cable identifiers between patch panels or termination blocks, the near end port identifier and the far end port identifier are used with a / between the two locations. The port located closest to the NDA in the cabling topology should be listed first in the identifier. Each end of the cable should be labeled with the same information. So you want to have the same information on each end of that cable run for clear identification and communication of what that cable supports as far as connectivity. So in this example, this cable connects port 03 on panel 45, located in cabinet AD04, to port 15 on panel 45 in the cabinet located at AF12 in the data center. The concept of the cable subsystems was introduced in TIA 606B. The identifier can be in one of two formats depending on whether the cable is terminated on a patch panel or terminated on a work area outlet. For patch panel terminated cables, a scheme of FS XY-R P/FS XP-R : P is used. For work area outlet terminated cables, the scheme is FS-AN. So we're supporting both schemes here depending on where that cable is going to be terminated. Similar to horizontal and backbone cables, the to and from locations are used on patch cables and equipment cord labels, except instead of using the / you're going to be using a backward /. Generally, patch cords are not a component of the structured cable system. They're considered more of a disposable device, and are not really managed and administered. But it makes sense in a lot of situations to actually have these labels so they're clear. It's easier to find the locations of the other end of the patch cord. The identifier in this example can be decoded to define the patch cord connected between cabinet AB04, panel 24, port 01 going to the same cabinet on panel 36, port 13. The other end of the patch cord would have a label with the same information, so it allows for clear identification of what that patch cord supports as far as connections. .606B expanded the identification of grounding and bonding systems from just the TMGB and the TGB that were required in 606A. The standard now requires instruction on the identification of the TMGB, the TGB's rack grounding bus bars, the mesh bonding network, and the bonding conductors for telecommunications, bonding backbone conductors, grounding equalizer conductors, and also bonding conductors. So it's expanded a whole lot into the actual administration and identification of all the bonding and grounding system. And there's a lot of good information in the TIA 606B standard that's worth checking out as far as grounding and bonding. So the grounding bus bar, this is the identification scheme for a grounding bus bar. The TMGB is the main bus bar in the network system. TGBs are other bus bars in the facility, and the RGBs are bus bars on racks and cabinets now. So it's, we're administering the whole system of grounding and bonding. In this example, this is the telecommunications main grounding bus bar that's located in room A on floor 1. So that was all the required identifiers for a Class 1 network. Looking at Class 2 identifiers, the following infrastructure elements need to be identified. All the identifiers we discussed in the Class 1, along with the building cabling subsystem 2 and 3, which are the backbone cables, the building cabling subsystem 2 and 3 ports, and then fire stopping locations. These are all that are required in a Class 2 network administration. So the building cabling and subsystem 2 and subsystem 3 backbone cabling identifiers are very similar to what you might have in a subsystem 1 cable identifier. You've got a to and from. Again, you're going to want to have the port that's closest to the NDA listed first in the identifier. So the identification scheme for a backbone cable indicates the to-from routing of the cable within that building. The near-end port identifier and the far-end port identifier are used with a / between the two locations. The port that's located closest to the NDA in the cabling topology should be listed first, and the end of the cable should also be labeled on both ends. The building backbone cable in this photo connects ports 01 through 12 on panel 20 in cabinet AE05 in the data center on floor 1, with ports 25 through 36 on panel 12 in rack A1 in the telecommunications space B on floor 3. So just by looking at that identifier on that cable, you can tell exactly where it's coming from and where it's going to without having to trace that cable. So it's very helpful to be using the 606 standard and also having proper labeling on your cables. Looking at the building cabling subsystem 2 and subsystem 3 backbone port identifiers, very similar to what we saw in subsystem 1. You've got a floor space, which is a floor space designation, the rack location, the panel location in that rack, and then a port position. And again, in this example, this port is position 12, located in the patch panel that's at RU24, and the cabinet's located at AB04 in the data center. Fire stop locations. The following is required identification scheme for fire stopping locations. Each fire stopping location shall be labeled at each location where the fire stopping is installed in each side of the penetrated barrier and within 300 millimeters of the fire stopping material. So the identifier for fire stopping would be an F, identifying the floor. Then the FSL designates a fire stop location. The N character would be a 1 or 2 or 4 numeric characters identifying the fire stop location. And then the hour rating would be enclosed in parentheses. So now the Class 3 identifier, we're moving from a single building to multiple buildings with multiple telecommunication spaces. And the following infrastructure elements need to be identified in a Class 3. Everything that we've looked at for Class 1 and Class 2 networks, along with the building identifier, the campus cable identifiers, and the campus pair or fiber identifier. So the identifier for a port in a Class 3 administration would be similar to a Class 1 or 2 format, with the addition of a prefix for the building designation. So in this example, we've added a building to the identifier. So we've got B for the building, floor space for the actual space in that building, the rack position, the panel position, and the port position. So this particular label could be identified as World Headquarters, Data Center 1 space, the rack at AB05, panel 40, and port 01. And then finally, we get to the Class 4 identifier. This is where you'd have a campus, multiple campuses. So Here we have identifiers that are required for class 1, 2, and 3, along with we're adding a campus or site identifier to the scheme. So the identifier for a port in a class 4 administration would be similar to class 3 with the addition of a prefix for the campus designation. So our identifier scheme would be C for campus, B for building, FS for the telecommunications space, XY for the rack location in that space, R for the panel position on the rack, and then P for the port position on that panel. So this example would indicate a port that's located on the Athens campus, building 0631, telecommunications space 3B, which is the space B on the 3rd floor, rack 1, panel position 12, and port position 04. So by using this scheme, you can take one individual port in a huge multi-campus network and know exactly where that port's located. And then using your records, you can know everything about that port that you might need to know just from this one identification scheme. So Section 12 of the TA 606B standard requires documentation of the network infrastructure elements. This can be in the form of a paper-based document for a simple system, spreadsheet, database, or specialized software for management of larger systems. Records for each component of the infrastructure should contain all information required by the standard, as well as have the capability to add user-defined information. Linkages support the retrieval of information from the infrastructure records. Usually the identifier is the primary key for records, but the user can assign any unique index as long as an alternative to the identifier. Records are the means by which information about a telecommunications infrastructure is communicated. A report may consist of an individual record, a group of records, or selected portions of one or more records. Specific purpose software can be used to provide the administration of the network infrastructure elements. These programs may provide technology to detect changes, update records, generate labels, or export data to other programs. Section 11.1 in the TIA 606B standard provides guidance on the requirements for infrastructure identifiers. Most important is that the identifiers should be easy to read and stay in place for the life of the network. So, it's very important that your labels be visible, that they be durable for the environment they are applied to, and they should be machine generated, so the text is easy to read and permanent. In addition to the data connections, there are other critical systems in a data center that should be identified. Labeling of the power system involves the labeling of the equipment and cables throughout the data center power chain, from the incoming utility feeds down to POUs and individual racks. Cooling system equipment and piping should also be identified. And then fire suppression and security systems should be identified. These are areas that are very important to the operation of your network, but are not necessarily covered by the TIA 606B standard. So your power systems, your mechanical systems, and your fire and security systems should all be properly identified. For identification of cabling, there are many styles of computer printable labels that are available. Products and materials are designed specifically for network applications. Some of the options available for cable marking are self-laminating labels. These are labels that are computer printed and then applied around a cable with a clear laminating cover to protect the printing. There's also a different variation of self-laminating labels called turntail labels, which apply similar to a soft lam, but they also give you the ability to slide and rotate the label for easier viewing. Flag labels are available for smaller diameter cables, also provide more labeling surface than a wraparound type label. Marker plates are available for labeling groups or bundles of cables or large diameter cables, like some of the power cables that you might have supporting your power systems. And there are also label cores that are available to label small diameter fiber cables to protect the cable from any damage from a label being applied directly to the cable. For identification of network components, there are many styles of computer printable labels that are available with products and materials that are designed specifically for network applications. These are labels that are available for laser printability, for thermal transfer printability, labels that are specifically designed for applications like labeling patch panels, labeling cabinet doors, even labels for putting your wall grid in place in the data center. As far as label generation devices, they're available as handheld printers, which are very convenient for labeling on location, desktop thermal transfer printers, laser printers, and then labeling software that supports the generation, creation, and printing of the labels on these different types of printers. So Patrick, that completes the overview of the TIA 606B standard. For more information on network identification, you can visit Panduit at www.panduit.com or also visit www.tiaonline.org where you can obtain a copy of the TIA 606B standard to go more into detail of the requirements and some of the different ways that you can properly identify your network infrastructure.
Jay, thanks very much for that presentation, that information. We do have a couple of questions for you, Jay, if we could keep you here on the line for just a few more minutes to answer a couple of those questions. Do you have a minute or two?
Yeah, absolutely. Great.
Thank you. Well, one of the questions that just came in asks about wireless LAN equipment, specifically asking if the 606B standard supports or recognizes or in any way calls for the labeling of wireless LAN equipment, such as wireless access points for enterprise environments and used in hotels as well. Anything outdoor mounted wireless communication devices, such as in small cell type networks. Anything in 606B that addresses wireless communications equipment.
Yeah, I don't think it specifically addresses that, but that would be treated as any port that you might have in your network. So it's going to have a location that would be part of the identifier. It's going to be supported by structured cabling from either a telecommunications room or some other cross-connect device. So it is going to have a location. So it's going to have a floor space location, and it's going to be supported by some other connection. So it definitely would fit into the standard, but I don't think it addresses it specifically as far as the administration of WAPs.
Got it. Another question for you points out that the slides and to the extent that you had visuals, they focused on cabinets and racks. Question is, does the 606B standard recommend identifying wall mount terminations that are not inside a cabinet or a rack?
Yeah, absolutely, and that was one of the things that the revision of 606B addressed is actually there's a whole section in there as far as how to identify wall-mounted equipment or cross connects or punch-down blocks, and there's several different methods that you can use to do that, whatever makes sense to you, but it's well defined, and it does address very well wall-mounted racks and equipment.
Excellent. The questions keep pouring in, Jay, so if I'm going to keep you on here as long as I can with these questions and your answers to them. One question asks if there is software capability that enables, cable management or the labeling of cables. Is there a software solution available?
Well, it does address a little bit. The standard does address a little bit as far as automated infrastructure management systems. And I'm on the committee that we're currently working on more information related to that. There are some systems out there in the market that could provide that. I'm not sure exactly what they're looking for as far as information.
Sure, and perhaps something that would require maybe more of a one-on-one offline type conversation.
Yeah,
got it. The market does. There are some such things in the market, but it sounds like maybe a wide-ranging conversation to have.
Yeah, absolutely.
Right. Another question asks, should a person apply the same labels on both ends of the cable? You went through the scheme. Is it fair to say that labeling scheme or that identification scheme should appear on a label on both sides of a cable?
Absolutely. Same information should be on both ends of the cable. The identification provides, it clearly communicates what this cable is supporting as far as connections in your network. And you definitely want the information on both ends. Again, you want the first identifier to be the port that's closest to your NDA. That's the convention that the standard is using as far as which one goes first in that scheme. So it's helpful to have it on both ends because then you know which ports are being supported no matter which end of the cable run that you're on.
Thanks, Jay. Another question actually kind of tags right onto that previous question. Asks, how often should the cables be labeled sort of along the run? Is it just at each end of the cable, a certain distance from the end of the cable alone, or is there a requirement that the cable be labeled every certain number of meters, along its path? Right.
The standard only calls out labeling both ends. It doesn't go into information as far as labeling it, at so many feet along the complete run. Certainly, in best practice, it might be worthwhile. I guess a lot of it depends on how you have your cables routed through pathways and so on. If there's designated pathways, supporting different areas of your network, then you may not need to label each cable, multiple times along the run. But yeah, in the standard, there's really nothing that calls out, that cables need to be labeled so many feet. Just basically labeling at each end of the cable where your reconnections are occurring. That's what's required by the standard.
Thank you, Jay. Another one asks about when cables penetrate walls or floor-to-ceiling penetrations. Is there a need or a requirement to label at those penetrations when they do either go through a wall or through a floor-ceiling combination?
Yes, that's the fire stop labeling and administration, and that's clearly defined in the standard as far as where you'd want to put those labels, what the information should have. Of course, you're going to label both sides of that penetration, whether it's each side of the wall or above and below cabinet ceiling penetration.
Excellent. Thank you very much. I think that, at least for the most part, takes care of the questions that did come in. Again, as we referenced during this Q&A, there may be some questions that require a more wide-ranging conversation. So perhaps there are some of those perhaps there's some of those in the queue here, and we did attempt to answer those questions that kind of can be pointed to right away and answered right away. So appreciate everybody's attendance today and those who submitted questions, and certainly, Jay, appreciate your presentation and the answers to the many questions that you had. So I'll wrap up by saying on behalf of Cabling Installation and Maintenance and its parent, Penwell Corporation, thanks again to today's speaker, Jay Whitaker, as well as to Panduit Corporation for making today's presentation happen and making it possible. A reminder to the members of our audience that this presentation will be archived within 24 hours of this live broadcast. It will be accessible from cablinginstall.com. You will receive an email letting you know that that archive is available for reviewing. We did have a few questions come in from audience members today asking about the ability to take a look at these slides again. I know there was a lot of information. So it will be available in archive. You will be able to come back and take another look and look at some of the detailed slides again once that archive is available, which should be within the next 24 hours. So in just a moment, we will sign off, and you'll see a window on your screen indicating you've successfully attended this event. That message will be followed by an email that you will receive. That email will bring you to your attendance certificate for today's webcast. If you do not receive such an email, please email us at the following address. It is one word, webcast material, WEBCASTMATERIAL at Penwell, PENNWELL.com. Penwell is the parent company of Cabling Installation and Maintenance. So if you do need an attendance certificate from today, please email webcastmaterial at penwell.com. We will verify your attendance and will issue you a certificate. So thanks once again to everybody for joining us today. Thank you to Panduit and to Jay Whitaker for the presentation, and we wish you all a good day. Thank you again.